Hey guys, so we're going to do a quick lesson today on z-scores and what those represent. Remember that make sure you do the lessons from last week and the week before, and then also complete these two lessons, because if you do all 6, then you'll get a 100 test grade. So make sure you have done them and you have passed them, because that's really the only way to try to make an impact on your grade right now. The daily grades really aren't having a huge impact, so we want to try to get those 6 done so we can do get that 100 test grade. Okay, and from the superintendent's message yesterday, it sounds like these 2 lessons will be our last 2 lessons. I'll get some more information on that today, but just keep that in mind to make sure you get these done. Okay, so a z-score indicates how many standard deviations a single data point is from the mean. So are they 3 standard deviations away? Is it 1.5 standard deviations away? This is also called our standard score. Okay, so a z-score can also be called a standard score, because basically what it allows us to do is it allows us to compare different types of scores to each other. So if you heard the phrase, you can only compare apples to apples. So you can only compare what I made on my Unit 6 test to what you made on your Unit 6 test. But what if we want to compare different data? So this standard score is going to allow us to compare different types of data, so you can see where they fall on that bell curve. So for example, if you want to compare what someone made on the ACT to what you made on the SAT, okay, your scores are going to look completely different, but there should be a way to say, hey, I did better than you on this, or you did better than me on this. So that's why schools can take either the ACT or the SAT, because there is a way to compare them. Okay, now if you just look at, I made a 25 on the ACT and you made a 1300 on the SAT, it's hard to tell who did better. Okay, so this is what our z-score is going to help us do. So our formula for a z-score, so we name the z-score with the z, so that helps. So z equals x minus mu over sigma. Okay, and I said the names of the symbols, but we'll talk about what all those mean. So x is your data point. Okay, like if you made a 50 on the test or a 25 on the ACT, that would be your data point. Okay, and these are reminders of our other ones. Mu represents the mean, and sigma represents the standard deviation. Okay, so if we want to calculate how many standard deviations something is away from the mean, then you take your data point and you subtract it from the mean, because that tells you its distance, and then you divide by the standard deviation so you can see how many of those you are away. So for example, the run scored by the Braves is an approximately normal distribution with a mean of 6 and a standard deviation of 3.4. Find the z-score for 11 runs. Okay, so 11 runs is going to be my data point or my raw score. And I kind of broke this down here because we need to find all 3 of these things. My mean is 6. And then our standard deviation is 3.4. Okay, and they'll give you most of the data. Your job is just to use it to help you find your z-score. So we need to figure out how many standard deviations is this 11 away from the mean. Okay, so we need to figure out how far apart these are. So we do our data point minus our mean. So 11 minus 6. And then we divide that by how big our standard deviations are. So 11 minus 6 is 5. And we're going to divide that by 3.4. And you do want the decimal. And we'll see a little bit more of why next time, but we'll round to the hundredths place. Can't really see that under my camera there, but that's 1.47. Okay, so the z-score for 11 runs is 1.47. Okay, this means 11 runs is 1.47 standard deviations away from the mean. Okay, so it asks you to create a bell curve and use the z-score to better understand the data. Basically, we'll do a little bit more of this on Wednesday, but your mean is always in the middle. If you remember our empirical rule from last week, and then 11.4 or 11 is my data point, so that's above the mean. So this tells you, okay, where it's going to fall within those standard deviations. So it's about 1.47. So last week we just did, add 1 standard deviation, add 2 standard deviations. This tells you exactly where it falls in between those values. Okay, so this is more of a visual. We're not going to do a lot of that today, but you'll be just working on calculating them. Okay, so now let's look at example 2 where we're actually going to use that to compare, because this is really where it's most useful. So Lewis earned an 80 on his biology midterm and a 78 on his history midterm. In the biology class, the mean score was a 75 and the standard deviation is 8. So I'm going to write that down. Biology, the mean was 75, standard deviation is 8. In the history class, the mean score is 72. And our standard deviation is 7. Okay, so so we have our data for the biology and the history class. So if you look at his scores, he made an 80 on his biology midterm, okay, and he made a 78 on his history midterm. So this one's a little bit harder to tell. Obviously, the 80 is higher than the 78, but if you compare it to how the class did, we want to see which one did he actually do better on. Because even though this is higher, the mean for our biology test was higher, and our mean for our history test was lower. So if we calculate our z-scores, we can see exactly how far above the mean he was for both of these. So for biology, he had an 80. So we're going to do 80 minus our mean, so 80 minus 75. And then we're going to divide that by 8. So that's 5 divided by 8, which is 0.63. Okay, we ran that. And then for history, he made a 78. So that's my data point. So I'm going to do 78 minus 72 and then divide that by 7. So 6 divided by 7. So that's 0.86. Okay, so even though his score was lower on the history exam, this z-score is bigger than this z-score. So it says, on which test did he do better compared to the rest of the class? So since this one has a larger z-score, okay, he's further away from the mean, more standard deviations away from the mean. So he actually did better in history compared to the rest of the class. Okay, and that standard deviation does matter because it tells you how spread out your values are. Okay, so this one had a little bit smaller standard deviations, so the scores were closer together. This one was a little bit bigger, so some of those scores may have been more spread out than on the history one. Okay, so that's comparing to, and you're just looking at their z-scores to see which one's higher, to see which one's further away. All right, and then one more. We're going to talk about how to use a z-score to actually find a data point. Okay, so on a recent test, Bill knows the average score was 88, so that's our mean. His teacher said his z-score is negative 1.9. So it must have been a math teacher because she was giving out z-scores instead of the actual scores. The standard deviation of the data is 8. We want to know, what did Bill get on the test? So we're not looking for the z-score, we're actually looking for his data point. Okay, so we know the z-score. So I'm going to write down our formula again so you can see what we can fill in. Okay, so we know the z-score is negative 1.9. So that's kind of like my answer here. We don't know what Bill made on the test. I'm going to leave that as X. Our mean was 88, so X minus 88. And then our standard deviation is 8. Okay, and this is a pretty good situation, like it is a normal situation, because sometimes you want to figure out where you need to fall or what score you need to make to fall into a certain category. So this is something that people would need to do, not just something mathematically made up here. Okay, so to solve for X, we need to multiply by 8. So 8 times negative 1.9 gives me negative 15.2 equals X minus 88. And then we add 88, and I get 72.8. Okay, so Bill's score is a 72.8. So if you notice, this z-score is negative, which means the data point is below the mean. Okay, because if you think about subtracting, if I did 72.8 minus 88, I'm going to get a negative value. So it does need to stay in this order because you do want some negative z-scores because that'll show you you're below the mean, and the positive z-scores will show you that you're above the mean. Okay, so it always needs to be your data point minus your mean. Okay, and we'll write that down just at this summary as well. So our summary of z-scores, it tells us whether a particular score is above, below, or even equal to the mean of the data set. So, and that depends on the sign of your z-score. Remember, it describes how many standard deviations a data point is away from the mean. So if a z-score has a value of 0, that means it's no standard deviations away from the mean, so it is exactly equal to the mean. Okay. If a z-score has a positive value, that means it's going to be above the mean. And if a z-score has a negative value, it's going to be below the mean. Okay, so next lesson, when we start putting this back to the bell curve like we did with the empirical rule, you basically have a bell curve based on z-scores. So that middle is going to be your mean, so where your z-score is 0. And then we'll go up just using z-scores, so 1, 2, and 3. And then you'll go down using z-scores as well. Okay, and that's called the standard curve or our standard scores. Okay, but for now, just focus on calculating them and using them to compare, and also being able to find the data point. So if you would complete that practice quizzes and just let me know if you have any questions.